Okay, so we're here talking about graphing linear inequalities today, and eventually we're going to get into systems of inequalities. So this chapter really starts off with graphing a line, identifying what a solution looks like on an inequality or a linear inequality, and what is a non-solution. So we've got a couple things to cover here, but the test actually or the review actually kind of lays it out nicely with starting you off with like, how would you describe what a solution to an inequality is? Well, a solution to an inequality is any point in the shaded area. So this would be a solution, this would be a solution, this would be a solution, this would be a solution. These are all solutions right here because they're all in that shaded area. Anything out here would be a non-solution. It would not work for that equation, okay? And then the second thing you have to pay attention to is if it's a dotted line, you don't include the line. So no solutions on the line. Okay, if this was a solid line, we would be including those solutions, and I'll make sure I review that again towards the. I'm sure there'll be a problem where we have a solid line, and then we'll make sure I address that issue. So any of these would be a yes. Any point over here, this would be no. And I would actually accept this on the test as well. Like you put points over here and you write yes in the shaded area, and a bunch of points over here and you say no in the non-shaded area. That would let me know very clearly that you understand that solutions are over here, solutions are not over here. Okay. All right, up next it says use the graph to determine whether each point is a solution or non-solution. Okay, so I'm looking at this graph. I got my shaded region over here and I have a dotted line, okay? So I'm looking for 0, 0. So 0, 0 is right there. So 0, 0, well, it's not in the shaded region, so it is a non-solution. Negative 3, 2, so I go negative 3 up 2. So negative 3, 2. It is in the shaded region, so it is a solution. Negative 1, 1, so I'm going to go negative 1, 1. All right, so this one is testing your knowledge on whether to include the solutions that are on the line or not. Well, this line is dotted, so this would be a non-solution. Okay, if this was a solid line, we would include it and it would be a solution. So be conscious of that on the test. And then we got negative 5, 0, so we're going to go over negative 5 and up 0. We got negative 5, 0, and that is a solution. All right, number 3. Okay, so we're just graphing the line. This is kind of just getting you back into the idea of what graphing lines are. And so we're going to start off with filling out what our slope is and our y-intercept just so that we remember, and that's negative 1 and 2, and then our y-intercept is 0, 2. So I'm looking for 0, 2 here, and then my slope is down 1 and over 2. So I've got a negative slope, so I should be kind of going up in that direction. And I am, okay, so I'm just going to graph. Okay, there we go, that one's done. Done deal. Just straight graphing a line. Now the second one, you'll notice that this is very similar in that there's a y, there's a slope, there's a y-intercept. The difference now is that this has an inequality sign and this has an equal sign. So this one, your solutions are only on the line. We're only finding solution points that can actually be on the line. If it's off the line, it can't be a part of the problem. Inequalities have a whole region shaded, okay? So we have y is greater than 3x minus 2. So same type of thing. Our slope is 3 over 1. There's a 1 under there if you didn't know it. And then you have a 0, negative 2 for y-intercept. And then this one has an equal sign on it, which means that the line is actually going to be solid. So I've got negative 2, and we have up 3 over 1, up 3 over 1. And we're going to draw our line here. And it's a solid line in this case. Okay. So solid line because it's got that equal to sign under it. All right. This one down here, this problem right here is a dotted line because it does not have an equal to sign under it. So just be ready for that on this one when it's a dotted line, and that's really the difference. Okay, so now we've got something new here. So now we have a test point. You notice that on the last one we did not have a test point. That's because it was a solid line. It was just a line. And this one we actually need to test, hey, are things on this side of the equation or this side of the line included in the solutions, or are things on this side of the line included in the solutions? Okay, so we are going to pick a test point, and I like picking test point 0, 0, especially if the line's not going through it. And that will allow us to make a lot of numbers go away. Zeros make things a little bit easier in this case. So we have 0 is greater than, so I said y is 0, so we're going to put y in for 0, substitute it in. And we can say 3 times 0, well, what's 3 times 0? Anything times 0 is 0. And so we're left with -2. And is 0 greater than -2? If this statement is true, is 0 greater than -2, then this solution is true, which means all solutions on this side of the line are true. So we would say true. Okay, 0 is greater than -2. Okay, and so we're going to shade where it's true. So that means if this is true on this side of the line, anything else on this side of the line is true. And that means if it's true on this side of the line, it's false over here. Okay. All right. So I'm sure we'll get some more examples in there. This one. Next up, we have graph and identify the slope, the y-intercept, and point check before you and the point you check for shading. Okay. So we have our slope is -4 over 3. I'm sorry, -3 over 4. A little dyslexic moment there. Sorry. We have 0. 4, and then we're going to see if we can pick our test point after we graph the line. So I've got +4, my slope is -3 over 4, so 1, 2, 3, and I've got 1, 2, 3, 4. And now this time, you'll remember I was telling you about in the last problem, this line was solid because there was an equal to sign under it. This line has no equal to sign under it, so this one's going to be dotted. Okay, and don't forget your arrows there. Arrows are important. All right, so now we've got to figure out which side do we shade. And we shade based on the test point. So we can pick 0, 0 again. So we have 0, 0 as our test point. And we're going to say 0 is less than, well, 3 over 4, that's kind of ugly, right? If you're not a big fan of fractions and you want to multiply by something that makes that fraction go away, 0 is a great number. Because you can say 3 over 4 times 0, well, it doesn't matter that it's a fraction, it's just 0, and we say 4. So is 0 less than 4? Well, 0 is less than 4, so this is true. So we shade where it's true. Everything is true on this side. Any point that you could pick, this point right here, you could pick this point right here, you could pick this point right here. And so it would take you literally forever if you were going to put enough points in there to make it shaded. So we just shade that side of it, right? Representing that anything that you pick on this side is a solution to this inequality. Anything that you pick on this side of the solution is not an inequality, or any solution you pick on this side of the inequality is not a solution, okay? All right, I'm going to make this a 2-part video, so I'll see you in a second.